Taylor with Young Engineers Today. This is a recap of the webinar that took place on Monday, the 20th of September. Okay? Monday the 21st. All right. All right, we're going to be using West Point Bridge Designer, Encounters Bridge Design Contest. This is a free software. You can enter their yearly competition that starts in January, but you can use the software at any point in time. Okay, we're going to be having a short competition for YEOT with the 5th and 6th grade. It opened up yesterday, and the competition will run through next Friday. The goal is to build the least expensive bridge, least expensive functional bridge. In the event of the tie, the earliest submission wins. Now, the winner will receive a gift certificate to Adafruit. Post your scores on Edmodo. You can submit as many designs as you like, but please note we would like screenshots showing the number of iterations in their design. So we can see your score, we can see how many times you've improved your project. Now, on their website, you can download either the Windows or Macintosh version of the software, and I'm going to just show you that real quick. Basically, if you go to the website, you want to go to Resources and Downloads, what I have highlighted here. If you go to Resources, Current Contest Software, you can download that from there, okay? Now, as we can continue forward with the presentation, I have also, between Mr. Dubik and I, we have posted the software itself. You just can download it off of Edmodo as well. Okay, when you open up West Point Bridge Builder, you run it for the first time, and every time, you'll have to create a new design. Now, basically, in this scenario, you are a civil engineer working for the State Department of Transportation. You're responsible for designing a truss bridge to carry a 2-lane highway across the river valley. Your objectives are to ensure what the bridge can carry its own weight. So we're looking at our dead load, which includes the weight of the reinforced concrete deck plus the weight of the standard truck load. That's the live load. So that's your first objective. Be able to carry a dead and live loads. Now, to keep the cost of the project as low as possible is your second objective. The widest the bridge will end up being is 44 meters, and the elevation as high as 24 meters. Now, we're not going to be entering a local contest, so you'll click no on this. Now, here you can change the span for the deck elevation. It goes as high as 24 all the way down to 0. But when you do this, the trade-off, if you change the span, is that you're going to change your excavation cost, meaning that valley that we just looked at, this will be dug away, all right, as you go lower, which changes your excavation costs. All right. Now, you also have, if you were to do a suspension bridge, you can add cables. One cable would be a cable style suspension, and 2 cables, your traditional suspension bridges. And these are for the anchorages. Okay. Now, you can do arch bridges, as you can see in the image here, with arch abutments, and you can change the height of your arch abutments. Okay. You can add a pier, a big support structure in the center. This will also trade-offs. Everything is going to have a different cost, and you can change the height of that pier. Okay. Now, if you click on that tab at the bottom, it shows you all your costs. And personally, I like to have this tab open when I'm changing things so I can see how it's affecting my overall cost. When you're starting to use this, please start off with a template. Makes it a lot easier for you to get an understanding of how this software works, okay, instead of starting without one. And you can put your name in it and because you are the designer. Okay, and then you click Finish. Now, some of the tools to build this bridge. We have our joints, our nodes, and each one of those costs $1,000. Fill in the ones that are gray. The joints in the bottom of the bridge do not need to be filled in. You can tell by that thick gray ring around them. Then we have our member tool. So this is like your connections between those joints, like the support materials. Now you can draw them individually, or if you hold down the mouse click and you drag with it, it will connect all of them at once, okay? And when you make these, and we'll be going over this shortly, all these members come in different types of sizes. They're hollow or solid, and 3 different types of materials. By using the arrow, you can click on a specific member. These individual members in the program will highlight it in the display and give you a certain data point on it on the left in your data collection area. Now, this is the simulation button. If you click here, you'll run a simulation. Now, one of roughly 3 things will happen. One, you will get this screen, and this will show you that, hey, my bridge has failed, but that's okay because then you can go back and iterative design, keep improving it. 2, your truck's going to go across successfully. You might have a little bit of bending, and you probably just want to go and tinker with it. Or 3, you won't get either of these. You'll just get a screen that pops up, and this shows you a bunch of triangles shifting and 4 examples how your bridge is not even close to the point where it needs to be to even run the testing, and which is fine. You just got to go in and keep improving. Okay. So now, back to the drawing board. If we click on this tool here, this will take us back to our drawing board area. Now we have a bunch of data from the test results. Now you can see which members failed and why. The ones with red slashes failed due to compression force. If you put your hands together and you push into one another, that force you're feeling is compression. Now the ones with blue slashes failed due to tension. By clicking on the members that highlight it in the load test. So blue compression is red and blue is tension. Tension, if you hook your fingers together and pull away from one another, that feeling you have is tension. Now, this is great because we found a lot of information we can improve our bridge. Now, what we can do is change the sizes, the length, and the height of the material, all right? So typically, we're going to change the outside to make those stronger, okay? Now, if you change it to 150 by 100, those 2 members now pass, but why? Your intuition may be to tell you that a larger object is stronger, but why and by how much, okay? Which leads to this, the moment of inertia, a quantity expressing a body's tendency to resist change. Similar but not to be confused with inertia, which is a property of matter by which it continues in its existing state of rest or uniform motion in a straight line unless the state is changed by an external force. And that's the equation there. We're just showing you that. That'll make more sense the older you get. All right. Now, notice the moment of inertia formula. There's only units for base and height. Nothing in the formula denotes the type of material. This is the general formula for any rectangular object. Some formulas use mass in the calculations. Now we're going to be looking at what these words mean, all right? So we're going to start looking at materials. So we have 3 types of materials. We have quenched and tempered steel, carbon steel, and high-strength low-alloyed steel. Okay? And each one has a trade-off. Let's focus now on what would be the best materials. Now, steel. Where is on the periodic table? Trick question. It's not. Steel is an alloy. Alloy is material made by combining 2 or more metallic elements to give greater strength or resistance to corrosion. Steel is a combination of what 2 elements? Carbon and iron. Now, stainless steel comes in many forms, but the main elements in stainless steel is Cr, Ni, and N. So chromium, nickel, and nitrogen. Now, carbon steel is the most common grade of structural steel, generally 0.26% carbon. There are many grades of carbon steel. Now, in here, our cost of carbon steel is $692.37 per meter, or roughly 3.2 feet. Now, high strength, low alloy high strength is obtained from small amounts of magnesium, niobium, and vanadium. Here, we're almost at $800 per meter, or 3.2 feet. Now, quench tempered alloy steel is similar to high strength, but undergoes a special heating process. But what I want you to notice, as these materials are stronger, their cost is going up, so there's a trade-off. The heating process is done after the metal cools. The temperature and the amount of time it is heated is precisely controlled. By doing this, we can change the internal structure of the material, changing either yield stress, elasticity, or plasticity. Elasticity is the tendency of solid material to return to original shape. For example, if you're pulling on a rubber band and you let it go, it returns to its original shape. Now, yield stress, indication of maximum stress that can be developed in material without causing plastic deformation. Read the point if you were on it and it will not return to its original position. Example, that same rubber band, you pull it and it breaks. I can't put it back to its original position now. The higher the number, the stronger the material. Okay. So now we start changing. This is going to take you a few times to test and change certain parts. It's supportive. What you'll notice is the parts that are a little bit thicker or a different material, they change the colors, okay? So change solid bar to hollow tube dimensions. So we change the outsides, we increase those and change their thickness. For the last two, we're going to change the structure of the material, change it from solid bar to hollow tube, okay? As you can see where I'm pointing. Now, why would you use hollow tube? Hint, to save money. To fix these two with solid carbon steel, all right, you can see that cost. To fix these two with hollow, that's $6,000 saving. But there is a trade-off between strength and money, okay? Now, only two left. How would you fix it? Remember, they are in blue, so they're being stressed through tension. So if I change those to high-strength alloyed steel, now this is where you can see your iterations, and this is where you can see your costs, okay? All right. Now, we'll continue this further in our next webinar on Wednesday. Thank you, and have a great day.